All right, in this video, I'm just going to introduce you to the resistor, symbol, which again appears in several different forms. The most common one and the one that I'm going to use is this little zigzag line. Probably important to draw it a little bit more zigzaggy because there are another component called an inductor, which we're going to learn about later, that looks pretty similar, but it's meant to be circular kind of coils rather than zigzags. So just make sure that when you draw a resistor, you don't draw it like this, because then someone will think it's an inductor, and it's not. It is a resistor. So that's one symbol. As we get into AC circuits and other types of circuits, you might see the resistor just drawn as like a box here, because there are different types of what are called impedances that we're not learning about yet, but we will eventually. And so instead of drawing the resistor symbol, we'll just draw the general impedance symbol, which is just this box, which can be representing a resistor or some other type of impedance. However, those are the main two, but I'm going to really focus on this one, and we're going to see those all throughout the class. And so if I have a circuit, again, let me just give me like a point A and a point B kind of thing like I've been doing, stick with the same theme. I'm going to have point A and point B here, and then I would take my resistor. I'm not going to copy and paste it because it's a little too big, but I'll just draw another one. I'm going to connect a resistor right here between points A and point A and B. And now what I could do in a circuit like this is I could apply Ohm's law, which we've seen. So I'm going to write it right here. V is equal to I times R. And this is a very important concept here. So let's say that I've got this voltage, I'm going to label it VA, and this voltage, I'm going to label it VB. And then I've got some current that's flowing through my circuit. I haven't mentioned it up to this point other than in the Ohm's law video, but we do call current I in electrical engineering. C is the speed of light, so we couldn't use the letter C. Not entirely sure where the letter I comes from. If somebody wants to tell me, that would be awesome, and then I can include that in future lecture material. But since we reserve I for current in complex numbers, we don't say that the square root of -1 is equal to I. Rather, we say that it's equal to J in engineering. So C was taken, so we use I for current, and then I was taken, so we use J for complex numbers. So just a little bit of the chaos in electrical engineering. So if I have a circuit that looks like this, I've got some resistance R, I've got some current I, and I've got some voltage at point A and some voltage at point B. If I have two of these quantities, I can solve for the third, okay? So let's say I knew, it seems like four quantities, but really what I'm talking about is the voltage across the resistor, which is VA minus VB. I can just call that VR if I want to. That's the voltage across my resistor, or the voltage drop across my resistor is what we would call it. It tells us the difference in voltage across the resistor, which is what Ohm's law cares about. Ohm's law doesn't care about VA, and it doesn't care about VB independently. It cares about the difference in voltage across my resistor, okay? So if VB was 10 and VA was 13, or VB was 100 and VA was 103, this circuit would behave exactly the same, because the difference would be exactly the same. It would be 3 volts across my resistor. So that is a very key concept, and I'm introducing that now. Keep that in mind as you use Ohm's law. What VA would be known as is a node voltage. It's the voltage on this node or wire, which again, I haven't talked about nodes yet, but I will very shortly. This wire has 103 volts. This wire has 100 volts. The difference across the resistor is 3 volts. That is what this V is in Ohm's law. V is equal to IR. So that's what we care about. And so just to make this complete, let's just say that I knew that this was a 1000 ohm resistor, okay? Then I would be able to solve for the current in my circuit. I could say V is equal to I times R, and I could say, oh, well, my V I know is VR, which is 103 minus 100, or 3 volts, right? And then that divided by R, which is 1,000, would give me I. And so 3 divided by 1,000 would be, I just say 3 milliamps. 3 milliamps. And so then I would have just solved for the current in my circuit. Okay, so that's just a little introduction to the resistor. This is, again, all introductory material. We haven't drawn a full circuit just yet, just introducing the concepts. And in the next video, I'm going to talk about the other elements of the circuit, which I haven't talked about yet, which are the wires, which I've been drawing and sort of explaining as we go, but I'll really just zero in on the wires, the junctions / nodes that I've been talking about, that I've been highlighting in yellow, and then I'll talk about ground. And then we will be ready to build and analyze circuits.